Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam FM on financial mathematics. You are given the following forward rates. From time 0 to time 1, with time counted in years, the rate is F01 equal to 2.33%. From time 1 to time 2, the rate is F12 equal to 2.51%. From time 2 to time 3, the rate is F23 equal to 2.64%. From time 3 to time 4, with time counted in years, the rate is F34 equals to 2.70%. Calculate the yield of a bond that pays coupons of $50 at time 2 and $60 at time 4, as well as a maturity payment of $1,000 at time 4. So the key point of this problem is that the yield of a bond is one interest rate used for discounting all of its cash flows that makes the price of the bond equal to the present value of the cash flows when the present value is calculated using that one interest rate. But we also have the market rates in this problem given by the forward rates that let us calculate the present value of the cash flows of the bond. 50 is paid at time 2, and if we discount it using the forward rate from time 0 to time 1, and then the rate from time 1 to time 2, which is the first expression in this first equation that you see here, so 50 divided by 1.0233, this 1.0233 is using the forward rate from time 0 to time 1. And then that's multiplied by 1.0251, which is using the forward rate from time 1 to time 2. This expression is the present value of $50 paid at time 2. And then there is $1,060 paid at time 4, and its present value is that $1,060 discounted from time 4 to time 3, effectively using the forward rate from time 3 to time 4, which is 2.7%, so that's why it's divided by 1.0270, counting from the right basically. Then from time, discounted from time 3 to time 2, using the rate of 2.64%, so that's where the expression 1.0264 comes from. And then the same rates as were used for discounting 50, now I used it for discounting 1,060 after it's already discounted to time 2. It's discounted then from time 2 to time 1 and from time 1 to time 0. And we make this equal to the present value of the cash flows, both of them, but calculated using one interest rate, and that one interest rate used for all cash flows. That's called the yield of the bond. Well, this expression now is an equation in which we need to find y. But let's just write, instead of finding y, let's just write z for 1 over 1 plus y squared. And then what this becomes, if you move everything to the right-hand side, then this becomes 1060z squared plus 50z minus, and the left-hand side basically calculated with the left-hand side is actually equal to approximately 1006.2914, and that's 0.29194. And this is a quadratic equation, and we just use the quadratic formula to find the two solutions. One is z is approximately equal to negative 0.9982, and the other one is positive 0.9510. Now, only the positive solution is feasible, the only one that makes sense. And from that, we calculate that 1 plus y squared is equal to 1 over 0.9510. And y is equal to, well, how would you solve this for y? You would take the square root of both sides and then subtract 1. So y is equal to square root of 1 over 0.91510 minus 1, and that's approximately 2.5419%, which is answer B. Please remember this is copyrighted material. The problem is written by me, and the solution is written by me. It was originally posted in 2010 as an exercise for ExamFM in a PDF file. Now it's posted as a video. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited. Good luck in your studies and good luck on the test.